Welcome back, class. In this next short video, what I want to show you is a close-up at the heart with the trabecular carneae and the papillary muscles and the chordae tendineae. I really want you to have an understanding of how this works. So here's the heart, here's the right atrium, here's the right ventricle, here's the left atrium and left ventricle. Here's the interventricular septum. That's that muscular wall between the right and left ventricle. The muscular layer in the atriums, those are called pectinate muscles, but down in the ventricles, they're called trabecular carneae. But the trabecular carneae has these extensions, these little hills, and these hills are called papillary muscles. We have them here too. These are called papillary muscles. They're extensions off the trabecular carneae in the ventricles. And you'll see these are the valves. That's a valve. Well, on the right side, that's the tricuspid valve. And on the left side, that's the bicuspid valve, aka mitral valve. Now we know when blood pools up, when the blood pools inside the ventricles and the pressure builds and builds and builds, we know that the ventricles contract inferior to superior. So you got all this pressure pushing upward, and it's going to force these to close. If it didn't have these tension wires, right, if it didn't have the chordae tendineae attached to them, then by the force and the pressure of the blood pushing up, these valves wouldn't just close, they'd probably overclose. There's no checking system. So as the blood pushes up, they just don't close, but because the pressure is so great, they'll overclose, and you can get the spilling or pooling of blood or the regurgitation of blood back into the right atrium and left atrium. So these chordae tendineae, these tension tendons attached to the valves to create a little additional tension to prevent prolapsing or inversion of the valves as the ventricles contract, pushing the blood upwards. So the mitral valve and the tricuspid valve, they're supported by the papillary muscles and the chordae tendineae. Those are the structures that prevent inversion of the mitral and tricuspid valve when the ventricles contract. So here are the papillary muscles. Here it's relaxed on the left side, and here it's contracted. So when there's contracting, there's tension that's being placed on the valves as they close. It prevents overclosure so blood doesn't spill back. In the relaxed state, there's slack on the chordae tendineae. When they're contracted, they're taut. They're taut and tense. That's what keeps these closed. All right, so those are very, very important. Okay, and the endocardium, this consists of endothelial cells, and these are the ones that are easily damaged, right? Endocardium, which is made up of endothelial cells, it's kind of similar to the internal layer of a blood vessel, right? The blood vessels have three layers to them: a tunica interna or tunica intima, which is endothelial, a tunica musculosa, which is smooth muscle, and a tunica externa, which is the outermost layer. And as blood flows through the lumen, it's this endothelial layer that is prone to damage, especially with high blood pressure or a person's homocysteine levels that are high, or blood sugar that's high, or smoker or fried foods and high blood sugar. All that damages the endothelial cells. And when these endothelial cells become damaged, that's when the body produces cholesterol to fix the blood vessel damage. Good place for our next break.